My explorations as a maker have taken many forms. I've made 3D printers with homemade brains and extruder assemblies, I've made FPV drones, given them custom flight controllers, and even flown them in a fireworks display. I've made high voltage power supplies, I've made a sword, I've made a plasma speaker, rockets, and rocket engines. But it wasn't until I discovered science fairs that I really hit my stride. For my first fair in 7th grade, I made fast-charging graphene supercapacitors and compared them to traditional means of storing electricity. The next year, I made different types of antennae for use with the software-defined radio to receive live images of the Earth from NOAA satellites overhead. For my next science fair project, I attempted something a little more ambitious. I integrated the procedures described in 2 scientific papers in order to 3D print piezoelectric composite materials in an accessible way, and I showed how the electrical and structural properties of these 3D prints can be customized by making them in the form of different types of lattice structures. I mixed a custom photopolymer resin, designed the test samples, printed them, dried and cured them with homemade lab equipment, polarized them with a 32 kilovolt power supply I made, tested their electricity output in response to a uniform impact force, and tested their structural properties with a tensile test machine I designed and built myself. This experiment ended up winning me funding for my coolest project yet, an eVTOL passenger aircraft. I started with small-scale tests, making a custom flight controller that had such good command of a multi-rotor that it remained stable even after one of its motors had been remotely disabled. I built a dynamometer to analyze multiple propulsion systems, testing whether their components were well matched to each other for efficiency. And I further increased the efficiency of these propulsion systems with this rotor shroud intake. Then I worked to design the final manned hexacopter, the logic circuitry, the propulsion system, and the mechanical structure. Many experiments and iterations later, I arrived at a design worth building. I verified the strength of the design of the frame with finite element analysis simulation, and built it in real life with welded aluminum tubing. And after a few weeks of soldering and programming, the hexacopter proved itself capable of stable, unconstrained flight with a 150-pound payload.